Hi guys, so this video is about titration calculation. So how you're going to calculate amounts of a substance, volume and concentration, also knowing the units in mole per decimeter cubed. And other systems like AP, they would use moles per liter, or sometimes the volume is expressed as centimeters cubed, which is also equivalent to milliliters. So now just a quick reminder of the concentration calculation. So basically concentration is moles of a solute divided by the volume of that solution. So the unit would be in moles per decimeter cubed. Okay, to calculate the number of moles of that solute, you would multiply the concentration of the solution given to you in moles per decimeter cubed, multiplied by the volume of that solution in cubic decimeters. So moving on, the reason why we conduct titrations is basically to neutralize an acid by an alkali. So therefore, this is the setup for titration reaction. We start to add the alkali to the acid or vice versa while adding an indicator. Over here we have methyl orange, so that this will indicate the neutralization point for us to know how much volume of one reagent is needed to be added in order to neutralize the other one. So the calculations involved will be around concentration and volume of these two reagents. The pieces of apparatus that we have are the burette, conical flask, safety pipette filler, as well as pipette. And we also have the nth point that we're looking for. And the titer is the solution that's going to be in the burette, and the analyte is going to be the solution in the conical flask. For now, we're just going to focus on the calculations, not on the process itself. But that would be the setup. And just to go through it briefly, just to have an idea, you are going to pipette into the conical flask a known volume of, because the pipette has a specific volume to it, 25 cubic centimeters or 10 cubic centimeters. So you will pipette that volume into the conical flask and then add a few drops of the indicator. And then in the burette, you're going to fill the solution with the other reagent, which is also called the titer. And then you start to add, slowly open the tap, and then see how much you run it through, and then you would see how much volume of the burette was needed to cause a color change in the indicator over here. Now, so that's an example of, that's an example of how, what kind of results you may have. So for example, you may know the concentration and the volume of the analyte, which is in the conical flask over here. So for example, the alkali was sodium hydroxide was in the conical flask. And we know that the concentration is 0.12 molars, which is 0.12 moles per decimeter cubed. It's just a shorthand or abbreviation for it. And then for the volume, we had used the pipette to transfer 10 cubic centimeters. Now to transfer convert cubic centimeters to decimeter cubed, we divide by 1,000. Now, moving on, the volume of the acid that we got here after titration, for example, could have been 13.6 cubic centimeters. So now what I have is the volume of the acid that I added, and I have the volume of the base or alkali, as well as the concentration. So the question will normally ask you, what is the concentration of this acid that you are using? Because that's normal, because you want to know how much what kind of solution are you going to add, and how much of that acid is going to be as a solute in that solution. Now, moving forward, here's an example. You basically need to write your balanced equation. Okay, why? Because you need your mole ratio, which is over here 2 to 1 between the alkali and the acid. So here the acid is H2SO4, sulfuric acid. Okay, and so you need that because that's where all of your calculations are going to be. Now, first thing you want to remember is that the moles for any reagent is going to be in concentration times volume, and therefore you're going to use that for your calculations. So for example, for sodium hydroxide over here, The concentration is CV, and for sulfuric acid, the concentration is also CV. Now, here's an example. You have 27.5 cubic centimeters of 0.2 mole per decimeter cubed of sulfuric acid is needed, which is basically this reagent, which is H2SO4. So we have of H2SO4, we're going to write V of H2SO4. This is equal to 27.5 cubic centimeters. And then if you want to convert it to decimeters cubed, you divide by 1,000. Then you have the concentration, which is 0.2 mole per decimeter cubed. Okay. And it's needed to titrate 25.0 cubic centimeters of sodium hydroxide solution. So here I have the volume of sodium hydroxide, and that's equal to 25.0 cubic centimeters. Now, having the balanced equation helps in the calculations, which is very important. So you have to make sure that your equation is balanced. The question asks you, what is the concentration of sodium hydroxide solution? Before that, they may ask you, what are the number of moles of the acid, let's say, in the solution? You could, if you were to follow these steps, you could find the number of moles by saying N equals C times V. In our case, we do have 27.5 cubic centimeters, and then therefore we need to convert them. However, let me just go back and redo this one. So if we were to calculate this, that would mean N for the acid, H2SO4, is equal to 0.2 mole per decimeter cubed. And you write it next to it if you don't have, underneath it, sorry, if you don't have space. And next to it, you will add 27.5 over 1,000, because you're going to divide and you're to make it in decimeter cubed. And that's how you get your moles of your acid, and you can work that out on the calculator, but just be careful of your significant figures. Always go for the minimum. So that could be a question that they may ask, or they may ask you about the concentration of sodium hydroxide. Now, this is a more than one step process, so I will show you now how it's done. As long as you wrote down what is given and then what is needed. So what is given are these values. Okay, I'm going to tick them and write them next to them. But what is unknown is the concentration of sodium hydroxide. I'm going to write a question mark here. So now we are going to substitute in these places. And I'm just going to clear out here what we have. And we're going to substitute. Basically, what we have is the concentration of the alkali is unknown over here, but I have the volume. Okay, so CV over here. And then for the acid, I have the concentration and I have the volume. Now, the ratio between them is 2 to 1. Okay. Now, in that case, I can make a mole ratio between them by cross multiplication. So therefore, it's going to be 2 times CV, and then I will substitute those values, 0.2 mole per decimeter cubed times 27.5 cubic centimeters equals 1 times all of this. And then I will solve for my unknown. So it will look like that. So it would be 2 coming from the mole ratio times the concentration times the volume on that side times, equals 1 times C times the volume. Okay? In this case, you will rearrange your equation, and then C is going to equal to all of this value. And then your final answer will be in mole per decimeter cubed. Here, you didn't have to convert your volume into decimeter cubed because they will cancel out here. Okay, so there is no need. However, when do you convert your volume? When they want you to find the moles only of one of them, because moles should have a concentration in mole per decimeter cubed and should have volume in decimeter cubed in order for these units to cancel out. And don't forget to find your answer in the smallest decimeter cubed. Okay, in the smallest significant figures. Now, here's an example. A student carried out a titration to find the concentration of sulfuric acid with this volume, 25 cubic centimeters. So we're going to write V of H2SO4. And he does not know the concentration of sulfuric acid. So we're going to write C of H2SO4 question mark. And then it was neutralized exactly by 34 of potassium hydroxide. So that is the volume of KOH, potassium hydroxide. And the solution concentration, the C of KOH, is equal to 2.0 mole per decimeter cubed. Okay. Now, to calculate the number of moles, so they gave you the equation, and you have now the mole ratio from the equation. That's why you need it. And if they didn't give it to you, you have to balance it yourself in order to complete it and balance it in order to get it. But for now, you're just going to have it ready and given. Calculate the number of moles of potassium hydroxide used. So moles equals N equals CV. N equals concentration of potassium hydroxide 2.0 mole per decimeter cubed times the volume. Now the volume is 34.0. Now divided by 1,000 to turn it into decimeter cubed. And your final answer should be in up to 2 significant figures. Why? Because here you have 3 significant figures and here you have 2 significant figures. So you go for the minimum. Okay, I'm going to leave it for you to do that calculation. I'm just showing you the method. To calculate the concentration of sulfuric acid in moles per decimeter cubed, we're going to do our the steps that I have over here. So the ratio between KOH to H2SO4 is 2 to 1. Now substitute CV and CV for each one of them. So C is unknown. C is known here. It's 2.0 times the volume, which was 34.0. And here I'm going to write mole per decimeter cubed, and here cubic centimeters. And here C is unknown question mark times the volume, which was 25.0 cubic centimeters. Now the next step you're going to do is you're going to cross multiply these values. So that would mean 2 times C, which is unknown for me, times 25.0 equals 1 times 2.0 times 34.0. And now to solve for C, C equals 1 times 2.0 times 34.0 divided by 2 over 25.0. Now, the 34 and the 25 have the same units, cubic centimeters, so they cancel out. The 2 has moles of units, of mole, which are moles per decimeter cubed, and the 1 and the 2 have no unit, they're moles, so they cancel out also. And the unit, I mean, and so your final unit is going to be in moles per decimeter cubed, so it's a concentration unit. And again, your answer should be up to 2 significant figures, because you have here 2 digits, 2 significant figures, and here you have 3, and here you have 3. So you go with the minimum. Okay, so that is how it is done. Here's another practice question that you could do. However, this one talks about, this is a full one that contains, the whole titration apparatus. So if you come across a question that talks about the apparatus or the indicator, you skip these and you just go for questions that focus on the moles and the concentration. So you can pause that and you can do it on your own. And then here's another question that you could also attempt to solve. The nice thing here about this question is that it asks you to find the mass in grams of sulfuric acid. So if you calculate the moles, you can actually go back and convert it into mass. So I'm going to show you how this is done. So 200 cubic centimeters of sodium hydroxide with this concentration, so that's C and that is V. It's good to label on the question. To prepare a sample of sodium sulfate, calculate the amount of moles of sodium hydroxide in this solution. So moles, N equals CV, N equals 0.300 mole per decimeter cubed times 200, and I'm going to divide by 1000. Okay, and that would be in decimeter cubed. You're going to write your answer over here. Okay, so now these are your moles of sodium hydroxide, NaOH. So important to keep writing which reagent it is. Calculate the amount of sulfuric acid needed to neutralize this reaction. Now, in this case, that would mean H2SO4 reacts with, you need to write your balanced equation in order to know the mole ratio. Okay, so they want you to use the mole ratio in order to calculate this. However, you would need to complete the equation in order to balance it. So therefore, that would be given to you at this point. In other boards, you might have covered that content, so you could actually balance it now and you would know the products. And the water here you have two. Okay, so you would need 2 moles here. Okay, so now this is aqueous, and this is aqueous, and this is liquid. Balancing wise, this is for mole ratio 1 to 2. If you found these moles of sodium hydroxide, you just substitute them. So that would mean it is 0.6 moles over here. And then you would find your N unknown over here of H2SO4. How would you find it? By cross multiplication. So now N equals 0.6 times 1 over 2, and that would be moles. Therefore, it is 0.3 moles. Okay? But now they want you to find the mass in grams of this acid. Therefore, mass is equal to N times MR. You're going to take these moles, okay, the 0.3 moles, and you will multiply them by the MR of sulfuric acid, meaning it is 2 times 1 for hydrogen plus 32 plus 16 times 4. And that would be in grams per mole. And then you would find your answer over here. Okay, I hope this was helpful. And that's the end of the video.